Hello guys. So today our topic is about temperature, okay? It seems very easy, right? So let's move into the first part. It's about thermometer, okay? So thermometer is a very basic apparatus in our daily life, right? Because sometimes you're getting a fever, you're using thermometer to measure your temperature, right? So you can see here, there are very basic structure for thermometers. And here you can find, here's like a bubble. In the bubble, we have some liquid inside of this. Sometimes it's alcohol or sometimes it's mercury, okay? And in the middle of the thermometer, here are the thread inside of this. It's a very small thread, okay? And you can find when temperature increases and it will make the liquid in the bubbles have expansion. And then once it expands, we can say here that it just increases its heat like this way, okay? And here is the thread inside of this. And then once it reaches to 100 degrees like this way, you can find here, maybe you can understand that you're measuring the boiling point for the water, right? Okay. So temperature is, thermometer is very like normally in the lab, and sometimes you can use it to measure the temperature, okay? It's a very basic measures. And I also have a question for you that why there are -5 and 105 degree right here? Because in the lab, we sometimes are using the 0 degree to measuring the melting point or like the freezing point, right? And maybe in 100 degree, because we are very easily to measure the boiling point, okay? So why we have to make the thermometer's total measurement from -5 to 105, okay? You can just think for this question for a few seconds, okay? Okay, so let's tell you the answer, okay? So for a thermometer, if we have a very short period from the total measuring distance, we can say that if we just from 0 to 100, if one time, like the temperature changes a little bit in your lab, okay? So maybe here you're using more temperature to measuring the boiling point. Like here is 101 degree, okay? So 100 is just an average measurement in the global, okay? So maybe some places 101, some places is 99, some places is 102, some places is 98, okay? So once you measure the 101 degree, that is very horrible, right? Because the total measuring, you only have 100 degree. So maybe it will make the thermometer have explosion, right? Because it fulfilled the thread, right? Like this way. So also for the ice, it just have a very low melting point. We can say that also that the liquids are filled in the alcohol, right? So it is also very horrible, and maybe it also can make expansion. So in our IGCSE test, some questions will ask you, what is advantages like using this way, like using that method? There are only two reasons. First reason is to increase our accuracy. Okay, make the accuracy increases. Okay, like why you are using this to like while you're using the isolator, we said that it can through heat transfer. Okay, that can preserve the heat. This is the way to increase the accuracy. Or like you're using a more advanced apparatus is also for accuracy. Okay, and second reason is about security. We are thinking the ways or like the method just from this week, like security. Like we are increasing the security for the total experiment. Okay, so there are the two reasons for thermometers using. And here we are choosing the second reason that is for security. Okay, and here we can find in the second slide we talked about the heat and transfer. And imagine you are placing two blocks right here, and the first block it includes like some ink inside of this. Okay, it's an ink. And in the second a tank, we can say maybe here it filled with water, okay? So here you can find, if you once like just make this paper throw away, and the ink just have to transfer into the water, right? Like this way from left to the right. Okay, so this is about heat and transfer, okay? So also the same as the temperature transfer, like heat transfer. If here have two blocks or have two rooms and here's a paper in the middle. And once we throw away the paper, we can find here the particles just traveling from the high temperature places to the low temperature places, okay? Just from the left to the right, okay? So here we have a conclusion that the heat just transfers from high temperature to low temperature, okay? And that heat transfer from high temperature to low temperature, like this way, okay? So here is for heat and transfer, okay? So here, after this, our last topic for today is about absolute zero, okay? And here, maybe you have to stay for a long time for this, okay? And in your daily life, maybe sometimes we're using Celsius degree, right? Because today, like it is 20 Celsius degree, like today is 30 Celsius degree, right? This is very normal. But in our physics, or in our lab, we are using the Kelvin temperature. Like here, it is Kelvin. So for the Kelvin temperature, we can say that there is a transfer between Kelvin and Celsius degree. That K equals to T plus 273 degrees, like this way. Okay, so here is a table for you to understand here. Like in the lab, like if you're measuring the melting ice's temperature, so for Celsius scale, we can say that there is 0 degree, right? It's very easy for you to understand. And for Kelvin scale, you can use in the formula that T is 0. And the Kelvin here is 273, like this way, okay? So here we can see that it's 273 Kelvin. And also in the boiling water, you can see that once the boiling water Celsius scale is 100 degree and its Kelvin scale is T equals to 100 and plus 273, the total sum is 373. And here it is 373 Kelvin, okay? And for absolute zero, we said that it means the Kelvin temperature equals to 0. And here to measure what is a Celsius degree. So here for this, you can find once the Kelvin temperature K equals to 0, so here T equals to negative 273 degree, right? So here we can say there is a temperature, okay? So this is for Kelvin's temperature and for the Celsius temperature, okay? And here we can find inside of the table Celsius scale and Kelvin scale. So maybe you have a question. So Mai Lin, I'm wondering, there is real absolute zero in the world. Okay. So for this question, I will give you a result for this. Like when I was a student, I remember that at that time I go to the different labs around the world. Sometimes I go to UK, sometimes I go to US, and also in China and in Singapore, I go to many universities to visit different labs. Okay. And at that time, I find that there are also maybe all the labs have the same problem that they want to reach absolute zero. Because using absolute zero, we can like design many very interesting experiment and try to find some new properties in the materials and for the physics concepts. Okay, and at that time, I found that maybe in the US and in China, they can reach about negative 272.9999, like this way. Sometimes it's 10 negative fourths and sometimes 10 negative six accuracy, okay? And here you can find they just moving the temperature very closely to absolute zero, but they cannot reach absolute zero. Okay, to remember this, they are very close to absolute zero, but they cannot reach absolute zero. So in the real world, maybe in the global view for absolute zero, there is no labs can reach absolute zero's temperature. We can maybe very close to this. Okay, so like for this view, we can say that this is not, we cannot blame for absolute zero that definition of this, but we have to blame for our materials and for our patterns. Okay, and maybe for our operations are not very accurate. Okay, so please remember this, that absolute zero we cannot reach at this time, but it indeed exists in our like daily life. Okay, it indeed exists, but it's our reason, it's our fault we cannot reach for this. Okay, so we can say absolute zero is a possible or lowest possible temperature. Okay, it's a very possible temperature, but it's our fault we cannot reach the temperature. Okay, this is the first reason you have to understand for this. Okay, and the second reason for absolute zero, we have to remember that for absolute zero, maybe here, we said that maybe it doesn't mean that all the particles or all molecules in your body doesn't have a vibrate. Okay, so you can find some very rich person, like the billionaires. Okay, like they have many money and they want to use them, and maybe they one time he or she has a cancer. Okay, and they cannot cure because nowadays the medical method for them is not very reasonable. So maybe here they are using the ice technology to make them sleeping in a tube, and in the tube there is absolute zero temperature inside of this. So maybe here for maybe after 30 years or after 40 years, they will wake up and they'll find in this way, maybe here the technology for medical cure increases and they can just cure for their diseases inside of their body. Okay. So you can find here that maybe they just live in the absolute zero places, but they're that means they cannot wake up anymore. Okay, and this means that absolute zero doesn't means your body just dies down or just maybe your molecules or like atoms, your body doesn't move, but they have a very little vibration inside of this. Okay. So not only for absolute zero, but also like for negative 100 degree, negative 200 degree, or negative 250 degree, they're always vibrate in the substance. Okay, please remember this. Always vibrate in substance or like a free motion. So we knew that there's always vibration and free motion in the body. So we cannot say that absolute zero is a starting temperature for vibrate. Okay, please remember that starting temperature means that maybe here for absolute zero doesn't move, doesn't vibrate, but for other temperature it moves or vibrates. Okay, so we cannot say that absolute zero is a starting temperature for vibration. Okay, this is not true. Okay, please remember this. In IGCSE past papers, some questions just ask this problem. Okay? So please remember this is very important for you to remind this. Okay. Okay. So let's move into an exercise here. You can find in these slides. So how to describe the phrase absolute zero in the four answers. Here you can choose the correct answer, please. Okay, so I believe that you have your answer, right? So this problem we are choosing A, right? This is the lowest possible temperature, right? Because we have already discussed about that absolute zero. Maybe right now we cannot reach the temperature that because our technology is restricted, and maybe our apparatus is not very advanced. Maybe our operations is not very correct. Okay, so this is for absolute zero. Okay, and for the particles in a solid, maybe we cannot say they start vibrating, right? Maybe we can only say that the particles in the substance maybe not start vibrating. Maybe it is like we can say that it's always vibrate or have a free motion, right? So we cannot just say that it's starting temperature for vibrate. Okay, the B is not correct. And for particles, we indeed have weight, right? Because weight equals to mass times gravity. We have nearly the forces part, right? So C is not also not correct. And for D, gravitational potential energy means GPE. Also, we learned before that it equals to mass times gravity times height, right? This is for the GPE, okay? So here is for the problem 8. We can only choose A, okay? So here our today's lesson is over, and hope you can understand for the episode 0 and clearly solve for some problems, okay? Okay, so see you next time. Bye.